Thanks for joining us. We are still working out a little technical issue with respect to the speakers, but we'll get started in the context of time. So I'm pleased to introduce Annie Flippo. Annie Flippo works as the head of data science and analytics at ThinkNear by ThinkNear, a mobile advertising platform. She is a data science expert focusing on the application of machine learning techniques to extract insights in the areas of marketing, media, and consumer behavior. Her focus is to make data science accessible, intuitive, and fun to learn for everyone. She'll be presenting a talk titled User Motivation, Refining Customer Segments with Location. Please join me in welcoming Annie.
Thank you. Can you guys all hear me? Apparently this mic only goes to the recorder, not on the speaker. So if you can't, just move a little bit closer. Thank you for coming to my talk. I see a lot of familiar faces. Thank you for your support and some new ones. So I work as the head of data science in ThinkNear. We're a mobile advertisement platform. We target people using location intelligence. Basically means where they are, who they are, and where they have been. So a little bit of a quick announcement. Yes, I am head of data science in ThinkNear. We were just purchased yesterday by InMarket. So now we're InMarket / ThinkNear. Traditionally, we had 3 pillars of digital advertising. So we all know, love and know all this stuff. Display, we know that. Search and social. But now there's mobile. A lot of people are now going mobile first. So when you're talking to your friends, you're arguing about some point, someone will take out their laptop and start typing. No, they take out their cell phone, right? So they take out their smartphones to figure out if you're telling the truth or just to fact check you. So we know this. And sometimes shopping is now mobile first. So mobile is now the 4th pillar of digital advertisement and actually starting to become leader of digital advertising. Because mobile advertisement is have additional information, which is the location. The location is context. So if you're going to car shopping, you're at the dealership, well, you have some apps, we know where you are, then we're like, hey, we just ran this ad, an AR ad for Acura, so we can target people who are in Acura. Maybe you're thinking of buying that car, but maybe not. Maybe we can motivate you to make this sale today. Or maybe you're at a competitor's lot. Maybe you're at Lexus. So we can target people where they are. So what is location intelligence? Basically, using location data to drive some insight, to solve some problem. So what is location data? It is the raw location data that's captured by SDKs in your app, mobile app only. So who here has a free app on their phone? Just a few. Everybody else pay for all their ads? Okay, me too. I only use free apps. So when you have a free app, they have to be able to pay their software engineers. They have to pay their AWS storage. They have to pay somebody to keep it running. So in order to pay, they have to monetize some space. And that space is the advertising space. So I'll show you a sample of location data. This is raw data. I say raw, quote unquote, because this is already cleaned up. So it's easy to see. So the location data has a handful of attributes that we really need. We have the advertiser ID. So the advertiser ID is the anonymized ID on your phone. So some people don't know this, but you can reset it anytime. If you're going to, if you're on an iPhone, it's under privacy advertising ID. You can always hit the little reset button, boom, we get a new ID. So we don't know who you are, we don't know your phone number. Then there's the timestamp. When you're going somewhere, at what point do we see you? The latitude, longitude, and horizontal accuracy. So from all that raw data, those are nice. We're just getting billions and billions of rows a day. That's really not enough to understand where people are. We have to kind of process that to find where people are going. Just because your raw latitude, longitude timestamp is not enough. So to pair up with a point of interest database, a POI database, which is basically a phone book of the world. And so you look up in this phone book, and then you can see that this latitude, longitude is mapped to buffalo wings. So now we know that you are going to a restaurant. We know later you go to a coffee shop. We know you're going to the mall. So this is called visit data. So with visit, we can slowly map your journey over days, weeks, months. All anonymously, of course. So that we know like you're the kind of person who likes to go to Starbucks, or do you like to go to Dunkin' Donuts? So what can we solve with location data? So let's say you're a retailer with customers. You're a McDonald's, say, or you're Wendy's, and you're standing in the middle of your place, and then people are coming in. Well, not everybody's the same, right? They have different people who are coming in. So who are your customers? Where else do they go? You know where they're coming into your store, but you don't know what happened when they leave your store. But with location data, we can track them over time. And then what motivates them? So that one is interesting. What motivates them? Like, Annie, how do you know what motivates them? So let's think about the traditional persona, soccer moms. Everybody know what a soccer mom is. Everybody has heard of a soccer mom. Basically, a soccer mom is actually a soccer parent, but it's nicer to say soccer mom. It's somebody who's married, have kids, and are quite active. So with location data, you can now, to do more hyper-focus segments, soccer moms can go to more traditional discount stores, such as Food for Less, Dollar Tree, or there's different kinds of soccer moms who go to Target and Whole Foods. So the more value-seeking soccer moms are value seekers. They want to be, economic in all their purchases. Whereas the people who go to Whole Foods are more affluent, perhaps. So these are separate types of soccer moms. So with location, we can actually use it to build more hyper-focused segments. So the segments are basically rooted on location intelligence, where people go in the physical world, as opposed to traditional personas are basically based on lifestyle, like income, ethnicity, marital status, that type of things. So what I have done at our company is to combine all of this. We combine the traditional attributes, which is all the demographic interests, and then we layer on all the location data. How is it made? This is always, everybody wants to ask me this because they want to do it at home. So here it is. So first, buy lots of data, have lots of your own data. Our data is one-on-one deterministic, meaning they're not modeled, meaning that you have an ad ID. I can say this person is 35 to 45, they're in this income bracket, they're married, and so on, right? So we have one-to-one deterministic visit and demographics. We have visitation pattern, that's just what I talked about, where people go, where their tendencies. We have offline interests. What is offline interest? Like, you subscribe to Food and Wine, you subscribe to golf magazines. When you subscribe to a magazine, that tells you what they're interested in. And then we have some online social behavior, so where you like something at a website. I like Maybelline, I like Clorox bleach, Everybody does that, like Clorox bleach. So then we get all this data and we put it through an algorithm. And then we cluster them based on what are they most alike in certain attributes. So why use machine learning? Because our marketing department wants us to say we use machine learning. Isn't that what they always say? No, I'm just kidding. We use it because our panel is just too big. We have our 40 million monthly active users. We have over 700 million visits per month, and we have 200 million mobile IDs with demographic interest and affinity. That's like, do you want to look at that data by yourself? No. So that's why I use machine learning, basically to sift through all that data to kind of understand how to group people together. And it's also, we want to do an unbiased way of grouping people, because a lot of traditional marketing agencies do surveys, and you can't survey 40 million people. That is just not cost effective. And sometimes they already have a persona in mind, like, oh, healthy, we want healthy and wealthy, because our protein bar is for the healthy and wealthy. But then maybe somebody else is interested in this protein bar. So we kind of use the data to drive our insights. Okay. What does the algorithm do? Okay. Well, I'm not really here to talk about the whole algorithm, but basically it's unsupervised cluster algorithm. So there's no right or wrong, which is great. No one can really score me whether I did a good job or not. So we use unsupervised, and we use the normal elbow method. We're trying to figure out how many clusters is the best performing in this group of data. And then we group these people together. We end up about 200,000 or 300,000 per group. And after the group, I don't know if you've done this before, but if you do clustering, you cluster them, what does the algorithm come out with? Cluster 1, cluster 2, cluster 3. You don't know anything about them. So after you get the number, the groupings, then we do what we call post-cluster analysis. Then we go back into the data and try to find what are these people most over-indexed for. Over-indexing is an industry term, meaning what do these people do more often than the national average? So if these people go to a golf course more often than the national average, then they are over-indexed for golf. We've done this for different industries: grocery, restaurant, retail, and automotive. And the slides at the beginning of the top of my slides are available in that bit.ly link. So at the end, I'll go back to it if you didn't catch it. Okay. Why do you make industry segment? Why don't you say, these are all the segments? Just one effort, get 40 cluster, there you go. We do industry segments because it's better to capture the traits of the industry. We can perform custom engineering, feature engineering per industry. And then we can do very detailed analysis on each cluster. So for example, restaurants is very different than automotive. Restaurant is like, do you go out often? Do you go out to expensive restaurant rarely on Fridays, or you're more like you go to Denny's every Saturday morning? Like different people have different behavior. So that may or may not be the same as automotive, which is I'm a eco-friendly person, so I want to buy an electric car. So those are a little bit different so that we can control the features built into the clusters. So challenges in using visit data. Now this is very important because visits are observed, meaning we don't see everybody all the time. We sample them a little bit over time. So that means they do not represent, the observed visits do not represent all the places a person go to. So you might miss some important visits, such as, a diner may not take out her phone during a very fine dining experience. Valentine's dinner, they're not going to take out the phone and play with their game. And then, and even if they take out their phone, we might not have an app that has the SDK that we need to capture that data. So observed. So how do you overcome this observed visit issue? Is to have a very large sample set and use very long time spans so that eventually we see people, if they're like a fine dining person, that we will eventually see them there. This way we can average out unobserved visits over a large group. And then another way to do it is to, bin them, basically. You can do percentages overall, so you can like low, medium, high visits to fine diners, or, rare and very rare or very often, kind of like separate into the two groups. Quantile is also good. This way, and I tell you from experience, if you onboard another data vendor or offboard another data vendor, your model should be pretty stable. All right, so here's some results from all this effort. Here's an example. Jackie, the convenience seeker diner type. So this person is over-index for female, over-index for 45 to 54, and in the middle income slice. Her interest is music and family. They have over-index for club membership, Costco, Sam's Club, things like that, home improvement. They go to Home Depot a lot, Lowe's, and things like that. It's an example of automotive. Harold, a mass market hybrid guy. He is over-indexed for male, middle age, higher income. He has more affinity for Toyota, so that's basically Prius, because Prius has been around so long. And other things that this person over-indexed for is fitness and outdoor sports, things like that. And we have much more detailed cards for all of our hyper-focused personas. So this is a sit-down and steakhouse person. So this group of people don't dine out often. They go to grocery stores often, but when they do go out, they go to a sit-down restaurant as opposed to a fast food like QSR. As opposed to these one. This is interesting. We didn't actually expect this group. We call them the fast foodies. The fast foodies are wealthy folks, educated, but they like to go to fast food. They like to go to their In-N-Out. They like to go to their Taco Bells. And we have a few of these people at our company. They go to Taco Bells all the time. Okay. So now that you have all these groups of folks, what can you do? Basically, two purposes. One is insights reporting, finding people who already are in our panel, like what are they interested in, and then targeting them. So I'll just give you an example. So this is Whole Foods. This is our hyper-focus segments. Whole Foods, people go to Whole Foods, so that visits, people go there. Over-index for eager exercisers, prosperous passengers. We have very great names for these as business travelers. Inexperienced and expecting, new parents. Okay, I didn't make this up. Thank you, marketing. Thank you. So these are like 6 months worth of Whole Foods visitors. How did they fall into this category? So I'll give you a couple of use cases. A protein shake brand sold in Costco. So their purpose, they tasked us to find people. So they only sell this protein shake brand in Costco, but they don't want to target everybody in Costco. That would be a waste of ad spend. So they say, we want to find people who are healthy-oriented, fitness-oriented. So we found these three groups, healthy and wealthy, lean and green, fitness enthusiasts, within Costco. And so we targeted them for a few months, and then they use a third party to measure us. So we don't measure ourselves. We use a third party. So they pixel the ad and make sure they go in and stuff. So those folks, the ones that we targeted versus when we didn't, they had a 23% lift in visits over the control group. So the second use case, so this is a large electronic retailer. I will not name who. So they want to capture holiday shoppers who are likely to buy electronics. This is kind of hard to find in traditional personas, like such as soccer moms. So we have two different personas for that, tech enthusiasts and deal seekers. So we target those folks. And so they make sure that we outperformed the traditional segments providers. So the traditional segment providers are Nielsen and Exalite. So we had ongoing campaigns using our segments and those guys. And then we had about 24 to 65% increase in CTR because that was their KPI over the traditional segments. So and that's it. I'll give back. So if you want a copy of the slides, it's right here, if you want to get it. So I'm open to questions. Oh, sorry. Okay.
You mind repeating the question if they ask because so that it gets recorded when they are.
Oh, okay. Yes?
Very basic question. So when you say national average, mean or median?
National average is, I have to check my calculations, but I believe it's average. So I know what you're talking about. Yeah. So the question is, over national average, we're using average as opposed to median. Any questions? Yes? What's a lift in visits? Lift in visit is we have a control group versus a exposed group. So if the exposed is over the control group, let's say the exposed group have 120 visits and the control group at 100, the 120 is 20 over the lift. So there will be 20% lift. Does that make sense? Okay. Yes?
So, looking at end-to-end data flow, what percentage of customers do you see in your practice who either disable sharing of location data, and what are the strategies to kind of get around that?
Right. So we can't even collect the data if they don't share. So if they have location service on, some apps as well using always on. So if they don't share, we cannot get it anyhow. So does that answer your question?
Sure. Do you have a sort of ballpark percentage of people who fall into that category across various segments?
I don't know because I don't know the data that I don't get. But the apps that we are partnered with are location kind of service apps. So if you don't have location on, it's very hard to use the app. It would be not a lot of value. Such as weather app, for example, kind of those kinds of apps. Yeah. Yeah. Any question? Yeah. Go ahead.
So how do you validate your models? Like once you have your clusters done and you use them to make some conclusions.
Yeah.
How long does it take you to validate them, and how do you validate them?
So that's a good question. Everybody asks, even marketing asks us that. How is it good?
People pay you guys a lot of money to come up with these results, so I would assume that they would want to double check.
Right. So we're continuously validating using our own money, doing test campaigns, and also clients will test with us. So this has been out since about January. So now we have about 8 months worth of data. Such as we do these things such as use cases to make sure that we're adding value to, the cluster has value. If it doesn't, if it's just as good as Exalite and Nielsen, don't use us.
So you just measure the KPI.
We just measure the KPI.
Your guys'
Yeah,
decisions that were made.
that's correct. Yes?
What's your clustering algorithm? You kind of remember that, I realize, is it proprietary?
No. We basically use k-means. We use all kinds of unsupervised. It's just any kind of group measuring algorithm. We use k-metoid, all kinds of stuff. But in the end, we chose k-means because it performs, and it's about the same answer as the other ones. Yeah. Go ahead.
Yeah, thank you for telling us how to reset the advertising index.
Within 2 days, we'll catch up to you.
Yeah, right. So as long as someone doesn't reset their advertising index between the time you do your cluster analysis, communicate it to your client, and then your client comes up with their advertising strategy, and then sends the advertising out, I assume, to that index, and that's the only way you can tell
Right.
a cluster. So if people are resetting it, what's your window between when you do your cluster analysis and the customer finally comes up
Right.
with their advertising?
So we did a study about that. So on average, the advertiser ID changes within 3 to 6 months. So if there's a major update on the software, you have to reboot, that changes it, and when you actually do it. But we do partner with a identity graph company, so every time you change it within 2 days or so, we'll catch up to you anyhow. So all the offline, the other data I mentioned, like all the interest, demographic and stuff, that data will match up with the new ad IDs. Does that make sense? Does that help? But all anonymously, of course. Oh, we don't know who you are.
All my behaviors that you had associated with my old index.
Yes.
A couple days of my behavior.
Yes.
You know what? We know who that guy
Yes.
is. We're just gonna
So there's a thing in the little secret, just between you and me and the camera. It's it's called the 10 to 4 rule. So where are you 10 p.m. to 4 a.m.? And where are you 10 a.m. to 4 p.m.? So most days. So we know approximately where you live. We don't know exactly, like we don't know your address. We can't send you a letter or anything. But we know what we call the block group. So that's how census collect data anyhow. So the census collect data on a block group level. So they have everything. They know all about you. And they actually repurpose that data, and you can download it for free on the census.gov whatever website. So, but they obviously aggregate it so to make sure not anything personal gets out. And other advertisers use it to do aggregation of other things. So there's a lot of gates in place to make sure no identity gets accidentally leaked out. Not that it's already leaked out already. I mean, like Target, Chase, what's the last one? Whoever, Equifax. But like we try not to experience. So they're also they're doing business off your data, and so are we. But we try very hard. We have a consortium of the advertiser group. I forget what it's called. We follow all the rules that they publish. So hopefully that answers your question. Yes.
How do you determine the number of clusters?
Oh, the number of clusters. So I just mentioned the elbow method. So if you say, I have 1 cluster, obviously that's no fun. That's not very interesting. 2, 3, 4. And then you go, da, 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 da. You have n number of users, you have n cluster. Also, that's not good. So somewhere between 1 and n. And then you start to look at the minimum square error to see if you add 1 more cluster, it starts to flatten out. So that's called the elbow method. I'm from Canada. I call it the hockey puck method. So eventually you find like the sweet spot. Yeah. So I want to be as small as possible, so I have to don't do as much analysis. So if it's like 9, I'm like, can we make it 6? So yeah.
We can take one last question.
Oh, one last question. Yeah, go ahead.
Quick question for you about the data collection. It looks like you're collecting patient data. Do you collect it from first-party sources outside of the bitstream, and if so, which ones?
We do not use bitstream at all. Bitstream is very, very inaccurate. So if anybody know what bitstream is, that is the auction data. Auction comes through about 14 or 15 exchanges, billions and billions a day. But the lat long is not that good. So we only collect data from SDKs. So we're in market now. We have first-party SDK. I haven't gone to the new company orientation, but it's about many millions. I don't know how many. And then we augment that with third-party data that we have partnership with, and we vetted out that data to make sure it's very accurate. So the SDK data is about 40 million plus and growing. Okay, thank you.
Okay, thanks a lot.
Oh, yeah.
A small token of appreciation, a short class.
Oh, Shaka, thank you.